Folks, hello and welcome to your week 6 discussion post. As I have been doing here, I thought I might give you a quick video here to get you started and get you launched off on this on the right foot. A lot going on this one. Let me go back here to the statement of the discussion post here. What you're going to do is go back to week 1 and pull your 2C function from there. That is a scenario where you have, I believe, one horizontal asymptote. And what we're going to do is we're going to try to, everybody's going to just try to come up with a practical application of what this graph is telling us, and then we're going to play around with the first and second derivative to kind of close out this section on differential calculus. So here's I don't know that I ever showed a 2C. I think I played around with 2A in my discussion post during week 1. So I just made up a 2C here. And again, this does have a horizontal asymptote because the degree of the numerator is less than the degree of the denominator. And what I'm going to use this for is I'm going to use this, I'm a golfer, and so what I'm going to say is that, that this function represents number of sets of golf clubs sold in thousands during the airing of a golf tournament, which typically spans about 4 hours, and you can see that here. So my horizontal axis will be time. I guess I could have used T, but we'll say X is time, since one of the marquee players that uses this certain brand tees off. So the player tees off at this time, and we'll say during the day that they've sold, I don't know, about 3.3. We'll say these are in thousands. So about 3,300 sets of golf clubs. And so the player tees off, and we'll see what happens to the sales after that. So in this discussion post, I think we're looking for a practical application of a piece of this graph. And I think what we're saying here is, or at least what I'm saying is, for this first hour, let's see, for this first, up to this point, maybe, let's see, about 35, 40 minutes into the round, it looks like the player's playing well. Golf club sales are going great. And then all of a sudden, let's see, what's going on? The instantaneous rate obviously is changing. Maybe the golfer, I don't know, hit one in the water or hit one out of bounds and took a couple of bogeys, double bogeys, whatever. And all of a sudden, everybody thinks it's the golf clubs and not the golfer. And so sales are starting to decrease, and the manufacturer is getting all excited. So that's what I'm looking at here. And again, thinking about this over the span of a typical golf round, which is about 4 hours. We'll just play this out to about here. So let's see. Let me see, what else do I notice about this curve? Let me kind of blow this up here. It looks like the function is increasing kind of at a decreasing rate. It looks like there's a little bit of a bend here that would kind of flatten out that tangent line here. So that looks good up to about this peak here. And obviously we should expect to see the value of the derivative be zero here, because we'll have a horizontal tangent. On the backside here, let's see, club sales are slow, and then or the decrease is slow, then the decrease picks up, and then the decrease kind of slacks off a little bit more. So the second derivative here is going to be valuable to us when we look at kind of this, not so much on this front half of the curve, which I say is about this piece right here, but on the back half, the value of that second derivative might get pretty interesting. So let me just turn on. So I took this function. I took the first derivative. I'm applying the quotient rule here. And then when I take the derivative of the constant over here, that's going to be 0. So if I turn on the value of the derivative, that seems to play out looking at this piece of the graph up until the point where the value of the derivative of 0. And that should certainly correspond, let's see, 0.639. This should be about 0.639. Yeah, and that's the maximum sales for the day. And that's obviously where we get the horizontal tangent. Let's see, and notice, because the value of the derivative is above the x-axis, so that we know that, let's see, the value of the derivative, or the instantaneous rate of change, is positive, but it is clearly decreasing. And that's what we get here. You notice these tangents will begin to kind of flatten out a little bit. So we're absolutely good here. On the back side, the value of the derivative looks to be negative for the let's see, for about the period of certainly out to the 4-hour mark, and that looks good, obviously. And this is my horizontal tangent here as well, so that that plays out pretty well using the first derivative to understand the slopes of the tangent lines. Now, what I'm going to be really interested in here is the second derivative. So let me turn off the first derivative. And I want everybody to please understand that the professor can still take a second derivative of, this was a monster, right? So I start with this, I take the derivative of this, and let's please put it on the record that the professor still knows how to take a second derivative after all these years. So this is my second derivative. I'm going to turn this on, and let's see if we can make sense of this. I'm going to actually sit up a little straighter in my chair here to make sure that I'm getting a good look at this. So the second derivative, what do we notice here? The value of the second derivative is negative from 0 until about 0.956 hour, 955. So about 95 hundredths of an hour. So 9 times 6, about 54 minutes in. The value is the value, or I should say this, not the value of the derivative, but the rate of change of the derivative is decreasing. And let's see, that all makes sense to me. Certainly decreasing to about a point at 0.955. So what are we saying here? Or about 955, yep. So if I curve trace here, what I'm saying at 0.955, 955, I think I can do this, 0.955, right about here, 955. It looks to me like the function reaches a maximum at about, like I said, 0.64 hours. Then we get this kind of this gradual decrease in the number of clubs that are being sold. And then all of a sudden we get this this is a kind of a bad point for the manufacturer right here. And this is played out right here on this portion of the graph from about 0.956 hours up to about 1.2 hours. And so 9.6 to 1.2, you can see that the steepness of this line is really, that's probably the steepest point on the curve. And this is where the rate of decrease of the derivative, or the rate of decrease of sales, is very high, and the manufacturer is not very happy. But then we get to this point on the graph, let's see, about 1.2 hours in, you notice that things begin to stabilize. So the tangent lines here are very steep, but at about 1.2 hours, they begin to flatten out a little more. So while the rate is decreasing, it is decreasing at a slower rate. And that's where you see this part of the second derivative. So again, one more time here, starting with my base function, this being number of units of golf club sets sold, where X is time, and I'm saying just X. Think of this from X from 0 to 4 over a 4-hour round of golf. The first derivative, again, is telling us what are the slopes of the tangent lines. Practically speaking here, one that you can see very easily is at the peak, that the value of the derivative, or the first derivative, is 0. So that's where we would expect to see a horizontal tangent. The fact that the value of the first derivative is above the x-axis up until that point tells you that the tangent lines are all positive. That's very clear. And then after the horizontal tangent, the value of the tangent lines, or the slopes of the tangent lines, are negative. That's very easy to see. What you're getting from this second derivative is basically the rate of increase and the rate of decrease. And again, I think the key points to note here from 0 to about 9.56 hours. Obviously, you have the value of the first derivative is positive here. It's negative over here. But the rate at which the increase is happening and the rate at which the decrease is happening is being explained by this portion of the second derivative. Again, this point here where the value of the second derivative is equal to 0 here is telling you that point of inflection where the manufacturer wasn't happy here, but he's really not happy here because this is a really, really bad period for the manufacturer because the rate at which sales are decreasing is the highest during the period of time. And then when you get to this point on the graph here, about 1.2 hours in, you will notice that the curve begins to flatten out a little bit. So your tangents will begin to flatten out a little bit, and the rate of change becomes not so significant. So this is a little more long-winded than I have been on these other discussion posts, but I hope this one, there's a lot going on here, and I, again, just wanted to make sure that everybody understands the basics of how to relate, or again, how to go from the base function to the first derivative. I think we've been very clear on that. But then going from the first derivative to the second derivative, what is this information telling us? So again, I hope this is helpful, and I look forward to a good week as we close out this section on differential calculus. If there's anything I can do for you, let me know.